Hi, everybody. Welcome to Limerick.NET-Azure User Group, or LDNA for short. Delighted to have Oren with us tonight to talk about Azure Cosmos DB. Just a bit of housekeeping before we get started. We do have a amount of about 50, I think, Microsoft exam vouchers that are available. Should anybody want them, the problem is you'll have to do the exam within 1 week because they expire at the end of the month. So drop your name in the chat or DM the Limerick.net Twitter account if you want to get your hands on one of those. But I think I will let Oren introduce himself and introduce his company and what he does and what his specialisms are. Thank you very much for joining us tonight.
Absolutely. Thank you for coming to this talk. And I want to talk to you today about Cosmos DB. This is going to be a somewhat advanced discussion. I'm not going to focus too much about code and details, but more about what it is and how do you actually make use of them. So my day job is at a company called Hibernating Rhinos. I build a database called RavenDB. We also build a set of tools that sit between your application and the database and give you insight about what's going on. I got started into Cosmos DB when we built this tool, which allows you to profile and look in more detail into what Cosmos DB actually can do. And a lot of the details that I have to share with you are about what are not your 4 steps when using Cosmos DB, but what is the second and tertiary steps that you have to take in order to create good applications. Before I do that, let's talk for a second about what Cosmos DB actually is. This is a globally distributed database service. It's been around for about 4 or 5 years. Before that, it originally was the backbone of OneNote, and a lot of the design consideration that it had there are still in place. If you go to the Azure website, you can see that you go to Azure Cosmos DB, and then you can define what you want. You can see that there are a lot of call it facets on the same thing. All of them end up doing the same thing, but the issue is what sort of optimization you have done. This is the recommended option. So, and that would work. Okay, there's a whole bunch of options here that I'm not going to walk you through, but you can see that this is probably one of the most interesting options, the ability to run in a geo redundancy, the ability to run and have multi-region write, all sorts of stuff like that. Some of those are things that you may not want to have. For example, if you use geo redundancy, you have to worry about GDPR and FAN because you may have data that is inside Europe and outside of Europe. But for the most part, those are things that are fairly well explained. Take into account choosing these options would significantly increase the cost of Cosmos DB, but we discuss on that more later on. Now, let's talk about, okay, what's the next step? We have a Cosmos DB database. What do you do with that? If you're used to a relational database, then you're used to have, okay, I have a database server. It has databases. There are tables, rows, columns, and stuff like that. The way that you model things inside of Cosmos DB is that you have the notion of a Azure Cosmos DB account, which has containers, and those containers contains documents. A document is typically a JSON document, which can be arbitrarily complex. However, that's somewhat of a misnomer. The documents in Cosmos DB are limited to 2 megabytes, and the access pattern that you have with the data is limited. What do you mean by that? You have to specify upfront what sort of queries you want. Okay, I want to be able to query by first name. I want to be able to query by a order date or something like that. By default, Cosmos DB would index all of your fields, which gives you the best options for queries. You just query over everything and everything works, including when you're working on data that is drastically different from one another. However, that works only up to a point, which brings me to what is probably the most important aspect of building an application that use Cosmos DB. And that is that you have to very explicitly design them for Cosmos DB. Otherwise, you're going to be hit with a lot of nasty surprises, not the least of which is a huge bill at the end of the month. By the way, I haven't said so, but please feel free to interrupt, ask questions. I would very much like this to be an interactive discussion and not just me talking to the screen for 45 minutes or so. So you really need to consider the strengths and weaknesses of Cosmos DB when you build the system. Now, for example, you can use the changelog of Cosmos to do some sort of business processes that gives me, oh, this document changed, this document changed. You don't get notification for the leech, which sucks, but that's still a very powerful feature. Now, let's talk about what sort of data can I throw into Cosmos DB. Now, the obvious thing is any sort of JSON document, but what would be a good idea to store? Can you give me an example of the type of application that you build and we can analyze that? Oh, we have someone in the chat. We have lots of stuff on the chat. Yeah. Okay, so for now, let's talk about a chat, because I don't see anything in the chat so far. Let's say that I wanted to model a chat rooms inside of Cosmos DB. What would be the data model? I have rooms, I have people, and I have the messages. It would be very natural to say, oh, you know what? Let's go ahead and define each room as a document. But where do I store the messages? I can store the messages as content inside of the room document, but that is severely limiting. Why is that? Because a document is limited to 2 megabytes. And even just a day's worth of discussion would very quickly be higher than that. I also going to have to deal with other limitations. For example, what happens if each message is an independent document? Then probably the number of documents that I have is going to explode. But let's consider it from a different perspective. What sort of queries am I going to need to run in a chat? And the answer is quite simple. I want to be able to ask questions such as, okay, give me the most recent messages for a particular room. That's probably the most common scenario that I have. How would I model something like that? Remember, it's very, very easy for me to get to, okay, let's just make a query. I'm used to that. The Cosmos DB, for the most part, will allow me to make that. But remember something really, really important. Globally distributed. Cosmos DB is a distributed database. That's part of its core function. And that's also why it has some limits into how it works. If I was building a chat system inside of a relational system, each message would be its own row. I would have an index on the room room ID and the date of the message, and that would be trivial. if I'm looking into how I'm modeling things inside of Cosmos DB, I have to think about what is the data distribution going to be like. I'm going to skip ahead and look at this. So we have the notion of partitioning. What is a partition? Partition is a set of documents that belong in the same location, basically. Now, in this case, what you see here is actually physical location. I'm saying I'm partitioning the data by city. Now, there are logical and physical partition that I have. A logical partition is what you see here, documents in London, documents in Paris. The Cosmos DB infrastructure may put all of these partitions inside of a single location. And here is another one. But the whole idea is that a partition is some scope. And what we tend to think about is the logical partition. And this matters because the logical partition has a 20 gigabyte maximum size. Now, it may be that they updated since the last check. This slide is about a year old, but there is a relatively small side to that. So again, going back to the chat application, how would I model something like that? Can I model something like this as can I model chat rooms and chat in general using this? What would be my partition key? For that matter, what is this? RUs. So let's go back a bit and talk about one of the core concepts in distributed databases. Distribution of data sucks. And I speak right now as someone who has been developing a distributed database for the past 15 years or so. So it sucks, it's hard, it's painful, and the way that Cosmos DB decided to manage that is to externalize costs directly to you. So there is something called request unit. The request unit is 1 kilobyte read, or 1 kilobyte of write, which is 5 request units. Now, the reason this matters is because you are charged on the number of request units per second that you use. There's a bunch of other things that going on, and there's a lot more complexity in the billing, but the basic idea is that you're paying per capacity, request units per second. Now, let's say that I have 50 users, each of them with 10 kilobyte documents. Each of them are reading, modifying every 5 seconds. So this is, again, 50 users in a chat room. Consider what is the impact now. Now I have 10 request units, but this is actually 50 because I'm reading 10 kilobyte. So that's, that's 100 request units per second, but I also modify that each second. So that's now 50 times this, and I start to make a mess. And you can see what does it look like. 10 requests per second, and this gets ridiculous quite quickly. It gets more ridiculous if you're running with a duty distribution or multi-master writes and things like that, because you require more from the underlying infrastructure. So let's go back here and discuss that. Let's say that my decision is to say, okay, each room is a partition key. So all messages to a room go to the same partition. That makes it very easy for me to model the data, right? But at the same time, it means that, okay, a room may only contain a maximum of 20 gigabyte. And a room may only have as much as 10K request units per second. 10K sounds like a lot, right? But let's say that I have 100 users. And that means that each user has a capacity of 100 RUs per second. Okay, let's say that I'm writing. I have 10 users, each of them is writing 1 document a second. Well, 10 users, 1 document a second, but they're writing 1 kilobyte. So now we are very near to the actual limit that we have. So that's something to take into account. Another thing that we have to take into account is hotspots. What do I mean by that? Let's say that I have 10,000 rooms. I have rooms about arachnophobia, and I also have rooms about pictures of cats. As you can imagine, the room about picture of cats tends to be a lot more active. So if my logic is throw everything into a single partition based on the room, the chat room for cats is likely going to be my hotspots. And that's going to be extremely painful for me. So notice that we haven't even talked about anything in detail, and now we're starting to face one of the hardest decisions in a distributed database. What is going to be my partition key? Now, you know what? Let's say that I don't want that. I want to choose the simplest possible option. I want to go with, okay, my partition key is going to be a GUID. And that's amazing because that means that now I don't need to worry about the max size of a logical partition. I can be pretty much guaranteed that the partitions are going to be small and meaningless. But what is now going to be the cost of asking, give me the recent post by room? That means that I'm going to now have to go and visit all of my partitions. That can be extremely expensive. Now, this is expensive in terms of time, but this is also expensive in terms of actual money, because the Cosmos DB design reflects actual cost to you. If we were using a relational database, we may need to scale up the database instance. We may have to wait a little bit. Cosmos DB would deliver the results, but they would charge you for that. And that can be painful because it's not always obvious what's going on. So let's go with that. Let's go and make assumptions. How would you model something like a chat room? What would be the partition unit that you would select? A really good scenario is to have the room ID and the current time. Why does it help? Because it means that, okay, I need to go to 1 or 2. Let's say that I'm saying that the partition is the room ID and the hour in which the message was posted. So the date and the hour. That means that I have segmented the data, the possibility that a single room would have enough messages to fill 20 gigabytes in single hour is unlikely. It also means that when I'm querying a specific set of data. Okay, go to 1, 2, 3 location. That's it. Because I may need to go to the last 3 hours. And I don't care about things that beyond that. So from the get-go, I need to think about how I'm going to model. I'm also going to need to think about what are the impacts of my queries. So consider this query. This is a Cosmos DB query. You can see that I'm querying from C. C is the container. There is no name for the table. And the documents inside the same container can have different shapes. But I'm doing this. And this actually turns to be a bug. What's the bug here? The query is case sensitive. So I fix it like this. Now, what's the impact of doing this? Well, there is a very small but very meaningful difference between these things. And the primary reason this is different is that one of them can use an index and one cannot. This one will use an index. This one will not use an index. Both of them would give you the results, but this one would have to do a scan through the data. Now, okay, so it's slightly slower. Why do I care? And the answer is that I'm getting charged per the number of writes that the infrastructure is making. So it's very easy to make a query that would cost me a lot of RUs, that cost me real money. How would I solve something like that in Cosmos? What would I do? And the answer here is that I would have to go and create a field, auto lowered, and use that, because that can be indexed. We have a question from Geert. I assume that's how we pronounce that. And the question is, if time is used as part of the partition key, does it not risk that partition being hot? Yes, it does. Absolutely. So going back here, let's say that I just posted a picture of a cat getting, I don't know, his ears waxed. And everyone is going gaga about that. And in order to do that, suddenly everyone is starting to, oh, bum, 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 and I might become very old. And yes, that sucks. At this point, you have a bunch of options. You may hit max capacity, and we see exactly what's going on then. You may go with adaptive capacity, in which case the Azure infrastructure would increase the capacity for you. Wait on that, there is an issue with this later. But in general, that's a problem. And in many cases, the best model, remember that the origin of Cosmos DB was one node. And in one node, the model that you have is a lot of small items that access independently. A really good example of that might be, oh, I want to build a messaging system. And the messaging system is going to say, okay, I'm sending a message to Carl, and that means that I'm creating a message with some random ID and random partition, and adding that ID to some known lookup that may reduce the amount of time. The idea is that we don't want to do a lot of queries. We want to do a lot more access by ID to independent values. In many cases, you would not use Cosmos DB as the end-all solution. You may want to use that as a part of your solution, especially for the parts that tends to go very big and may need high scale. Okay, so let's go and continue. So again, here, in order to handle that, I need to do two things. One, lower auto field, but I would also now need to go and update all of my existing documents. So again, something that may be as simple as this, and in a relational database, that would be, okay, let's define the collation on the field and deploy an index, can be something quite expensive to do on Cosmos. So let's talk about indexes for a while. Indexes cost you RU. They cost you RU on writes, and they cost you RU on reads. The default is index everything. Now, let's assume that they have a 100 kilobyte document, which isn't really that surprising. What would be the cost of indexing that? Well, it's going to be 100 RUs, it's going to be 500 RUs to store the document, and then probably another 1,000 RUs to store all of the relevant indexes. So the typical way that you do that is that you have to define indexing policies. What paths do you want to do that? Notice that unlike traditional relational databases, you can define composite indexes, but they're only useful for sorting, not for querying. You have the usual hash and range indexes, and something really important, adding an index is something that you can do, but it is costly. Again, you have to reread all of your documents. It takes a while. It's not something that you do. So you tend to think upfront about the kind of queries and operations that you want to do. Now, here are a few really important factors. The maximum size is 2 megabytes. It's just big enough that you generally not have to think about it, and not big enough for you to actually get away with that in most cases. The maximum response size is 4 megabytes. What does it mean? It means that if I have my orders document are 1 megabyte each, I'm saying give me the most recent 10 documents, I will not get that. I will get an error. Same things with requests. The requests are limited to 5 seconds. Again, this is all because the database is distributed. And those are things that a database does to protect itself. But you have to take it into account in your system. Now, you can do projections from the data. If you want to show a list of orders, you probably don't need the whole order. You just need the headers. But those are things that you have to be very aware of. Okay. You have transactions, sort of. They're not real transactions in the global sense of the word. Again, 2 megabyte max modification, 5 seconds max duration, and there you have to write a store procedure to do that. And they only affect a single partition. That means that if you are trying to do something like this, you cannot do the typical model of, okay, let's send money from one account and make that transaction. It would not work. And you have to think about the fellow cases of what happened if I had a partial success or something like that. Again, the model and the way that Cosmos DB work pushes you toward working with single documents that are operate on independently. You generally don't want to do a lot of queries. You don't have access to real aggregation or something like that in a way that makes sense. Now, let's talk about capacity. You have your buying RUs per second. Now, let's talk about this case. I have 2 partitions, and each one of those has, and I purchased 18,000 RUs per second. So this is what I have. Remember, a partition is limited to 10K RUs per second. This is what I get. Now, I increased that by just a little bit. But now I have 9,000 RUs here, but I can't put it here. So I split it. Now consider what if the load here is 6,000 RUs. Now I don't have enough.
There is a question in the chat. Can you address?
Aside from grid, I'm not seeing anything.
think that was answered. Second.
Yeah, there is one from if time is used as a part of the partition key.
I answered that. Yeah.
Okay, thanks.
Yes. So again, you have to take that into account, and it's very easy to. I'm just slightly increasing and the capacity, but you actually decrease the capacity. And again, those are things that you just have to know and understand. There aren't good tooling to see the heat map of your partitions. You have to know log about that, and or maybe open a support call with Microsoft to see that. And this is fun. What happens if you have too much load on the system? You start getting this issue. Now, too many requests, this is an error. What do you do then? The header for this say, oh, try again in X amount of time, typically 1 or 2 seconds. And you can retry, but think about what it means from the perspective of our users. My application went from taking a few milliseconds to taking multiple seconds to respond. And in many cases, that's something that is very bad. That's why capacity planning and understanding the partitioning scheme is really important for the system. Again, I brought those numbers from a year ago, so made it slightly different. But look at those numbers: 100 RU per second, 23, auto scale, 350. So you can go with pay by the number of RUs that you use, and storage, which is not really that relevant. This is probably the easiest for you to get started with, because you don't have to manage things on your own. But let's talk about what this means. Let's say that my load is 500 RUs per second. That means that 500 RUs per second, let's say, for 12 hours a day is times 30. So that's perfect. You can see that it's basically going to cost me almost nothing. Except that as I start to grow, sorry, 500 times, let's say I said 12. Okay. Now, so I have to, let me do it again, so you can see the whole number. So 500 RUs per second, time seconds in an hour, 12 hours a day times 30 days. Okay, so divided by 1 million. So that would be the fee. I'm ignoring this because it doesn't usually matter. Not that bad. I could have maybe saved some money in here, but not that meaningful. Something, however, that is really, truly important to understand: if you're operating at the scale of hundreds to low thousands of dollars per month, Cosmos DB makes 0 sense. Why is that? And the answer is that it is limited, it is complicated, it is costly. And you don't need that. You don't have enough capacity and requirements to actually need that. Let's do it this way. Let's say that I want to run, I have a large data set. I have to run, let's say, 0.5 terabyte, 512 gigabyte of data, and I need something like high availability, so I need at least 3 copies of the data. and I need to process, let's say, 250 queries or requests per second. Let's go here and look at this one. I can get this instance, 4 cores and 16 GB for $100 a month. I can probably go to the, here we go. This is 200, let's go for the 400, which is, I think, here we go. So 8 cores, 32 GB for $220 a month. This is an instance that has high, where is that? So this is have a SSD, which is really great for databases. I'm going to get 3 of them. So the cost of this $660 per month. And that is going to be able to handle far greater load with much higher flexibility. I'm going to want to use Cosmos DB when the size of my data, the number of queries, the size that I'm dealing with is enormous. Too big for me to just store in a standard a cluster of a relational database, RavenDB, something, and I don't want to deal with that. Again, because of the limitation that we discussed. And at that point, we have to start talking about how do we optimize the cost. So you can see here, this is the actual query that I'm running. Here is, and this is a query by ID. But you can see that this cost me 2 RUs, and probably because of the size of the document. And this is now, sorry, this is when I'm doing a query. I can do a read by ID, so like this. And now this is much, much cheaper. What's the difference between those two? Here, I did not specify what my partition key is. Here I did. So in here, I had to scan multiple partitions. You can see that they have more RUs. In here, I specify what the partition keys, just one of them. It also has an impact in terms of performance. In this case, I was running that for my local systems. You would typically run that from Azure instances, so the latency to Cosmos DB would be cheaper. Okay. Now, let's talk a little bit about the impact. You can see that if you're using Cosmos DB properly, you're probably paying a lot for that. Why? Because, which is funny, if you're using it properly, you're paying a lot for that. Because if you're not paying a lot for Cosmos DB, that probably means that you shouldn't be using that in the first place. You have to think about your model upfront. What sort of queries do I want to? Can I do queries by ID? Can I do that efficiently? I prefer small documents and look into the whatever I can do queries externally. There is cognitive services, there is a elastic integration that you can use. You can also decide on something like, okay, I'm going to, in the chat example, I'm going to store the messages inside of Cosmos DB, but I'm going to say, okay, here are the IDs of the documents, of the recent messages, those are going to store in another data store and query over that. So that's split the data. In many cases, using Cosmos is part of a polyglot strategy, not a single solution. Something that is problematic in some cases, backups and restores. You have backup and you can define between every hour or to every 24 hours, but you can only have 2 backups. That's it. In many cases, you need more than that. And restoring from backup is not something that you do. You call support and ask to do that, and that takes a while. the assumption is that if you need backups, then you don't care about the restore procedures or something like that. You also assume that Cosmos will not go down, and for the most part, it has been a pretty stable service, I think. Finally, this is actually something that happened just a few weeks ago. There is a security research company called Wiz, and they figure out that there is an issue with Jupyter Notebook integration that allow you to pull the access keys, the considered to be the username and password for many actively used Cosmos DB systems. The issue was patched within a few days, but something to pay attention to. Again, Cosmos looks to be very generic. It has a lot of APIs. You can do Graph, you can do SQL, Mongo API, Cassandra, etc. But it's not. It's something that you have to really consider how to make use of. And in many cases, it's best if you just throw the data in, maybe process that through the change feed. So user would write something, you would read it from the change feed and add that to some other location and read from that. And a large part of the design for Cosmos is to be aware of the cost structure, because it matters quite a lot into how you deal with that. And now is time for questions. 45 minutes exactly.
That's perfect timing, Oren. In fact, you got a late start there, so that's about 40 minutes all in. That's great.
Okay.
Thank you very, very much. So, has anybody got any questions for Oren? Wants to turn the camera on, turn the mic on, or either Oren just ask some questions?
I have a question. So I looked at Cosmos DB like 4 years ago, maybe, or if it was 5. So I assume that a lot happened since then. I have 2 questions. One question, one thing I thought was really good. But the first question is, so they have really priced for the resources you use. And somehow we are always paying for the resources you use, right? Mm-hmm. But would you say that they are very expensive in this way for how you're using the resources? Sounds like that, but I know that you've written RavenDB, which I've also been following for a lot of time. But so would you say that it's more expensive if you compare?
Yes. To allow, again, it's about use cases. If you want to store 100 terabytes of data and you want to be able to throw, let's talk about a really good use case for Cosmos DB. Let's say that I'm building a game and I expect that to be extremely successful. Let's talk about the Pokemon Go, something that used to be the craze. Okay, so now I have millions or tens of millions of users who are pushing data, each one of them independent of one another. And I can set things up that I would have effectively infinite scale. I have the amount of data that a single user can generate is limited. My partition key is the user. And that's really good for me. Also for gaming, you pretty much don't need a lot of queries. And if I need to do features such as leaderboards or things like that, I can scrape that through the change feed. And so that's something that would be a really good use case for Cosmos, especially because, okay, I can just not really have to think about that scenario. If you're talking about a business application where the data is a lot more intermeshed and you have a lot more operations, then the number of queries that you have is drastically higher, then I would say that it's a lot cheaper to go and run a database directly, especially because for most business systems, the likelihood you're going to get to 100 terabytes of data very quickly and need to be operating off the data is a lot less relevant. So the question is, what is the scenario that you have in mind?
Yeah.
And you said that you had another question?
Yeah, it was more something I noticed when my business was looking at it a couple of years ago, which I was amazed about. And it's you showed how easy it was to just turn on geo-replication. But what I saw was the way you could just, well, we want the better performance, and you just pull the what's called the slider, and you could immediately see the performance going up. It was really cool because it was quite kind of instant. And while being using HSQL, for example, it takes time to scale up and scale down. So that was just something really cool. And I'm just curious if you have that in RavenDB as well, this easy scale up model.
Assume that you're talking about this, and in this case, you would do something like this. And
yeah, exactly. How fast will you say that will be? I'm just curious.
To apply this,
yeah,
you would start to see the impact within 2 minutes of hitting OK, maybe 4, and the overall process to upgrade or downgrade the resource utilization would take something in the order of 10 to 15 minutes.
Okay, yeah, that's very neat. Okay, so thank you for the presentation.
Absolutely.
Okay, excellent. Has anybody else any questions? If you don't want to come off your mic, you can type them in chat, and I'll read them in the Salish accent for you. Nope, maybe not. Can you see that chat there, Oren? From
Second. Yeah. It seems that is from Wim, I think.
Yes, it is.
It seems that there is a specific use case for Cosmos DB and that it needs quite a large scale to make sense. Is there a patch to use a relation database force and then transfer to Cosmos DB, or are you running into problems? Interesting question. The immediate answer that I have to give would be probably no, but that's probably not fair. I would say that I don't think that I would ever recommend starting with Cosmos DB from the get-go. Even if I had what is likely to be the immediate, unless again, I'm talking about the game and I know that I have to expect a large scale and perfect use case for that. I would say that part of standard modeling practice today is to partition the system into resources, into services, sorry. And part of the key concept of services is that a service is independent. You don't integrate between services at the database level. So that means that gives you a lot of flexibility already. And the typical way that a system goes is that you have, let's say, this is your system, and now suddenly this one starts growing up in terms of capacity, scale, etc., while most of the other things remains the same. For example, if I'm talking about a social network, the number of users is mostly static, but the number of posts would be growing. So At that point, you're going to say, okay, I can see that my internal systems, here is the piece that is growing. Let's, but now one of the interesting that happened when you grow a part of system, it is because of the scale, you have to be very structured in how you approach that, which is perfect if you want to move to something like Cosmos, because now you have that structure. So my recommendation would be to typically create the typical service-oriented architecture with proper separation at the data plane level. When you start seeing, okay, in 3 to 6 months, I'm going to have scaling issues, then once you have actual practical experience about what sort of queries and operation you have, you can say, okay, let's shift the backend of this particular service to Cosmos DB. And then I can also migrate all of the data. And there are all sorts of strategies on how you can do that on a live system, with including being able to do a duplicate work. And that allows you to do things in with zero downtime and still migrate all of the data. I hope that this answered your question. But for the most part, yeah, I would only use that for high scale stuff, not for the itty-bitty parts. You want a lot more flexibility if you don't need the full capacity.
Okay, excellent. Thanks for the question, Wim, and thank you again, Oren, for answering. So, if any, give it another minute or two to see if anybody wants to ask any further questions. But if not, Oren, thank you very, very much for joining us at Limerick.net Azure User Group tonight. Fantastic. Oh, Peter's typing, so I'll stop talking while Peter's typing. Oh, okay. You're welcome, Peter. You're welcome. But yeah. Thanks again, everybody, for joining us at LDNA. Oren, thank you very much. Insightful into Cosmos DB. I'm hoping we can find a massive, enormous, I think is the word you use case for Cosmos DB, just so I can say that I've architected it or designed it for a customer. So thank you again for joining us. And next month at the LDNA user group, we have Jackson Felden joining us from Avanade, who is presenting on Microsoft Defender for Endpoint. That's 21st of October, if I can read Meetup correctly.
Yeah.
So thanks a lot. So the session was recorded. It'll be up on YouTube in a day or two. And